Welcome to problem 4.3d, where we just plow on with our calculations. So what we have here is we want to find out if the log normal distribution or the inverse gamma distribution has the heavier tail. So what we have here is the written up densities of the log normal and inverse gamma distributions, where it is assumed that mu is some real value and sigma squared, alpha, and beta are all positive values. So let's take a look at the ratio of the densities. So consider the ratio of densities given as h of x, where I choose the density of the log normal distribution to be in the numerator, and I choose the density of the inverse gamma distribution to be in the denominator. So again, this means that if this ratio tends to infinity as x tends to infinity, then the log normal distribution is the one with the heavier tail. However, if the ratio tends towards 0, then it means the inverse gamma distribution has the heaviest tail. So let's just write in what this is proportional to. So I remove the constants that are just kind of in the way, and what I have then is 1 over x multiplied by e to the minus 1 over 2 sigma squared log x minus mu squared, and then divided by x to the minus 1 plus alpha multiplied by e to the minus beta x. And what we note here is that this x cancels out with the x to the minus first here, so essentially what we have down here is just x to the alpha. Again, as in the earlier exercises, we kind of note it's a better idea to take the log of the ratio instead, because I have e to the something and e to the something. So I consider instead the log of the ratio of densities, and that is given as log of the ratio of constants. That is not written here because of this symbol, so that log of the ratio of constants, I would just denote that by k, plus log of this expression here. So in the denominator, in the numerator, I have log of e to the minus all of this, and that is just minus 1 over 2 sigma squared multiplied by log x minus mu squared. And in the denominator, I have, it is, the division sign gives me a minus, and then I have minus log of x to the alpha, and then minus beta x, which is plus beta x. I think I forgot to write the division sign here. It's beta over x. Very nice. So what I see here now is what happens when x goes towards 0. So when x goes towards, when x goes towards infinity. So when x goes towards infinity, then this thing goes towards 0, because x is in the denominator here. And this thing goes towards infinity with a minus in the front because of this minus. And this thing goes towards minus infinity as well. So all in all, the log of the ratio here goes towards minus infinity as x goes towards infinity. Oh wow, that was surprisingly neat, and that's very nice. So in conclusion, when the log ratio goes towards minus infinity, that means that the ratio itself goes towards 0, which then means that the density in the denominator is the one that has the distribution with the heaviest tail. So in conclusion, the inverse gamma distribution has the heaviest tail, regardless of parameter, has the heaviest tail.